Hello dear students, welcome to the lecture 3 of Artificial Intelligence and Machine Learning. This week I would like to start with showing you an actual example of decision trees. So I will compose a .NET Core console application to show you example of decision trees on a real world data example. Okay, console of .NET Core. Okay, artificial intelligence source codes. Let's say example. When you are working with machine learning or artificial intelligence, you should use the open source frameworks as much as possible. Unless you need to modify the algorithm or improve the algorithm, uh, you shouldn't try to code the algorithm yourself. Okay, because you will likely to make mistakes, you will likely to get poorer results or performance, and in many cases you will likely to fail to code the algorithm because these algorithms are hard, complex usually, and why reinvent the wheel? Meanwhile, you can use the invented wheel yourself. Okay, so I'm going to use NuGet packages of .NET Framework. And from here, okay, so there are several libraries. Accord Machine Learning is one of the best machine learning libraries out there. Okay, so Accord Machine Learning is one of the best libraries out there for machine learning tasks in C Sharp. You see, there are also other frameworks. Some of them are related and some of them are not. I'm going to install AccordNet machine learning, and okay, I accept, and let's find an example. You see it has many methods. Okay, there is an example. Okay, so this is a simple example. Okay, it is installed. I will copy paste this exactly as it is. Okay, famous example, they have already coded it. Let's first start with the simple example. Okay, so this is XOR example. In XOR, if 0 and 0, it is 0. If XOR, what is XOR if you ask?
Exclusive or exclusive disjunction is a logical operation that outputs true only when inputs differ. One is true, the other is false.
So the output is like this: 0, 0, 0, 0, 1, 1, 1, 0, 1, and 1, 1, 0. Okay, so we are going to build a tree based on this XOR algorithm. Okay, so you see, currently it says we don't have the necessary libraries in the context, so I am going to add using Accord Machine Learning Decision Tree Learning, and I still need Accord Math Optimization Losses. Okay, I have added both. So I need to represent this to the computer in a way that will represent the data. This one is easy because it works with true and falses. So this is the input data. The method of ID3 in uh, Accord framework takes a double array. You see, this is a double array, which means that it is an array of array. In this case, we are using integers. I think it also supports double, or maybe not. Let me check it out. Yeah, it doesn't support double, it supports only integers. Sorry about that. So the inputs are like this. This is an integer array 0, 0. This is an integer array 0, 1. This is an integer array 1, 0. And this is an integer array 1, 1. So this compose integer array of integer arrays. Okay. So the output is the result. You see in uh, classification, decision trees are supervised learning. So I have to provide the answers of each condition, each feature set. So each one here is a feature set, and the result of these feature sets are with the same order these, and these. So when the inputs are 0 and 0, the output is 0. When the inputs are 0 and 1, the output is 1. When the inputs are 1 and 0, the output is 1. And when the inputs are 1 and 1, the output is 0. So I have perfectly converted my real world data to the computer's understanding way. I have converted my real world data perfectly to the features that represented real world data. So I create an ID3 learning algorithm instance like this, okay. Then I learn the model. So let's go with step by step. I have put a breakpoint here. I run the application. Currently, this won't run because I didn't call the function. I didn't call the method. Okay, and I close the application and call the method. Okay. Okay, so our algorithm instance of learner is initialized, and then it will learn a model based on the inputs and outputs. You see the inputs are like this and the outputs are like this. So it will learn a model, and yes, it learned the model. So this is a model of accord.machineLearning.decision tree. So this is an object of decision tree class that belongs to the this class series, and it has the features. It has the features that accord machine learning defined, so it has some attributes: input count, number of classes, number of inputs, number of outputs, output classes, and the root of the tree, then the branches of the tree, and the branches of the branches, and such. So this is same as the tree we saw the previous week, okay, for this input. And I will compute the error in learning. So to compute the error, it uses 0, 1 loss class that takes input as output, the real input, and calculate the loss with the output of the model. You see, to compute the output of the model, it used 3 decide input. Okay, we can also decide ourselves. By the way, we are using the input dataset as a test here, so this is not the proper way of doing success, but this will calculate the success of the learning, not the algorithm itself. Okay, I'm going to restart. And okay, so the output is, as you can see, an integer array which is 0, 1, 1, 0. So our success rate is 100% because we have successfully decided the each input. You see, input takes an array, an array of integer arrays. And I will calculate the error. So error is 0 because all is successfully predicted, and the predicted array set is here. Okay. So this was an easy example. Now there is a better example, better fits to real world data, and we will go with that. Okay. Okay. I'm going to copy paste this, and let's read it. Okay, so this requires some more extra framework library. So I am using Accord Statistics filter. I'm going to use decision trees. I'm going to use system data. I'm going to use course math. I am going to use Accord itself. Okay, so anything else is left? Okay, nothing is left. So in this example, we will be using the famous play tennis example by Tom Mitchell. 19. I will make this read by the software. How am I going to do that? I can do that with. I can do that from here.
In this example, we will be using the famous play tennis example by Tom Mitchell, 1998. In Mitchell's example, one would like to infer if a person would play tennis or not, based solely on 4 input variables. Those variables are all categorical, meaning that there is no order between the possible values for the variable, i.e. there is no order relationship between sunny and rain, one is not bigger nor smaller than the other, but are just distinct. Moreover, the rows, or instances presented above represent days in which the behavior of the person has been registered and annotated, pretty much building our set of observation instances for learning. Note, this example uses data tables to represent the input data, but this is not required.
Okay, so they have used data tables, which makes it easier for us to understand. Okay, so it composes here a data table with the table name. Okay, so this is a table name. You can consider this as a Excel table. Okay, this is very similar to Excel table. I can even put this to Excel table, or in our previous lesson there was a page explaining this. Let's open it. Okay. Okay, let's see if it is the same dataset. Rainy, hot, high, false, no. Rainy, hot, high, windy equal to false, windy. Okay. Okay, this has some more variables, so I will look a better example exactly as this one, so that you can have a better idea. Yes. Okay, so this is exactly the same data table set, as you can see. This is just for labeling each instance of data. So this is as a whole a data set, a set of data perhaps, and when all is considered, this is a data set. For training set, we can also exclude some of them from the training set and use as a test set. Okay, and so these are labels of the instances. These are the output classes. PlayTennis is our output class. Okay, so we have the idea of the data of this example, and we add column names. The column names are the names here as of table names, and then we add the data rows like this. Okay, okay, so let's read more. Okay, just okay, let's read more, then I will run the application.
In order to try to learn a decision tree, we will first convert this problem to a more simpler representation. Since all variables are categories, it does not matter if they are represented as strings or numbers, since both are just symbols for the event they represent. Since numbers are more easily representable than text string, we will convert the problem to use a discrete alphabet through the use of a chord, statistics, filters, codification codebook, less than, para greater than. A codebook effectively transforms any distinct possible value for a variable into an integer symbol. For example, sunny could as well be represented by the integer label 0, overcast by 1, rain by 2, and the same goes by for the other variables. So, less than, para greater than, create a new codification codebook to convert strings into integer symbols.
We could also convert them into integers. Like I could say sunny word is 0, hard word is 1, high word is 2, weak word is 3, and no word is 4, and sunny word is 1. So I write here 1, and I write here 2, 3, and this will be 5. So we are turning categories into the integers, but they are not related as numerical. Uh, they are not like 2 bigger than 1. We are just representing them as distinct integer values, because many of the algorithms, when they are programmed, they work with integers or floating point numbers. It depends on the algorithm itself, and you are supposed to codify your data set into the way that your algorithm take as an input. Okay, so this is feature generation, and it is one of the hardest part of machine learning. Whatever you are working with, you have to convert your data into the feature set that your algorithm can process, that the framework you are using can process. Okay, so they have a codification method, they use it. So I'm going to put a breakpoint here, and let's check the data we have. Okay. Okay, so we have now a data table. When I click to show it, yes, you can see the column names, okay, here, and each one of the rows. Okay, we could fetch this from a database or from an Excel file into a data table. So this is just a structured data for now. And then I will codify this. Okay, codification. So codification method, actually codification is a class of, okay, codification takes as an input data, table data, and some other overload. So it can be empty, it can take data, it can take param strings columns, it can take column name and string values and such. Okay, so easiest one looks like a data table. So this is a method of codification class of, I am guessing that, okay, accord, probably accord or some other subclass. Okay, let's continue from here. Okay, then,
Translate our training data into integer symbols using our codebook.
so these are integer symbols, not integer values. If they were integer values, they would be meaningful, like 3 is bigger than 2 or 5 is equal to 2 plus 3. But these are categorical symbols, so they don't have such relations. Okay, don't get confused with that. And I move to the next step. So now I have a code book. Okay, it has 6 columns and it has some dictionary. So the dictionary has key and values, you see. Okay, this is the way they coded, so we need to check how they code. Then we apply apply method to generate data table of symbols. Okay, now our data converted into the symbols, and let's read it. Okay, so this is the symbol representation of the data. Okay, so it holds each one's values in another place. So how did it make this data generated? It generated data based on each column. For the day column, this is 0, 1, 2, 3, 4, 5. As you can see, it starts from 0, 0, and it will end with 13. Okay, yes, 13. So for the outlook column, by the way, in machine learning, each feature can only be compared with the same feature. So here the features are day label. You see day 1, day 2, day 3. Outlook label. So outlook is a feature of outlook. It can be a sunny, overcast, rain. So you can only compare outlook between outlook. So you can compare sunny with overcast. However, you can't compare sunny with hot because they are different features. All right. This is really important when you are comparing each different instance of data. In this case, each row is a data instance. You can compare only the same feature. For example, you can't compare temperature feature with humidity feature. So you can't compare temperature of day 1 with humidity of day 2. Day 1 temperature can be compared with day 2 temperature. All right. So it labels each data within that feature. So in this case, sunny will be 0, overcast will be 1, rain will be 2. And since it has 3 distinct data, we will see 0, 1, and 2, as you can see. For humidity or for temperature, there will be hot, mild, cool. So we will see 0, 1, and 2. 0, 1, and 2. For humidity, we will have high and normal. So we will and strong or no high, I guess. Yes. So there will be 0 and 1 and the same. So this is how it generated symbol integers for the data. And then it converts that symbols into an array based on the you see the column labels. Okay. You could also do all of these with your own coding. However, they have coded methods for these tasks, so you don't spend time. So we will see the inputs as integer array. So you see each instance of data is represented as an integer array. So when we check the first one, we see 0, 0, 0. And when we check 0, 0, 0, 0, so this will be 0, 0, 0, and 1. So when we check the second data in the list, it will be 0, 0, 1. You see? So this is the representation of this symbol, symbolized data with the correct order, and I will then it is converting the output into the output array. So here the output, you see 0, 0, 1, 1, 1, 0, 1, and I can also verify it from here 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, and you can also see it from here. It will be 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0. Okay. So then the rest is same. Let's read the comments here.
For this task, in which we have only categorical variables, the simplest choice to induce a decision tree is to use the ID3 algorithm by Quinlan. Let's do it. Create a teacher ID3 algorithm.
Okay, so we compose ID3 algorithm here. And okay, it is composed with here with taking decision variables. Let's read it. So this means that it is initialized with these features. Okay.
Now that we already have our learning input-output pairs, we should specify our decision tree. We will be trying to build a tree to predict the last column, entitled Play Tennis. For this, we will be using the outlook, temperature, humidity, and wind as predictors variables which we will use for our decision. Since those are categorical, we must specify, at the moment of creation of our tree, the characteristics of each of those variables.
Okay, so we have also provided the possible values, and this can be also dynamically provided. However, it is manually provided. And okay, it says,
Note, it is also possible to create a decision variable from a codebook. Decision variable attributes equals decision variable from codebook.
okay, so this is also possible. And however, they have provided this manually. And then we learn the model with inputs and outputs. Okay. And then it generated us a model of tree. Then we compute the error and see whether it has perfectly learned or not. So the error rate is 0, yes. So it can predict every input here 100% correctly. Then we transform a new data into the query to test whether it can, let's say, guess it, predict it correctly. So this one is sunny, hot, high, strong. Let's see if there is any input like that in the original data. Sunny, yes, we have sunny. Then hot, do we have hot? Yes, we have hot. Then high. Okay, we have high. And then strong. Do we have strong? Yes. So this is this one, day 2. So it should predict as no. So this is the query. It is 001. Based on the code book we have generated. You can code every one of these yourself. However, this is just making your job easier. So the predicted is 0, and we will translate it back to the string by using our play tennis column of the codebook. And the answer is, as you can see, no. So I'm going to make this some a static algorithm to make user enter inputs and, let's say, get the result output. So I'm going to say private and uh, model. So this model will initialize this. To do that, I need a data table. The new data. I have to make it static. And my custom data table. This is not important. And then I'm going to add this value as my custom data table. Okay. Okay. So okay, let's continue. All right. Then you see everything we are coding manually here can be automated with your coding abilities and skills. It totally depends on you. And I will need a code book, a static code book. Let's say from this data. To do this, however, I need to make it like this. Code book. Oh, I mean, it is codification. My codebook will be give codification from my data. I will be able to use it, and then I will apply this. Data symbols, inputs, okay, from the code here, and the data will be here. And okay, you see they have updated their to array method. However, the old one still works, and it will be initialized like this. ID3. Okay, let's remove. Okay, then we'll learn our model here. Okay, so this will be our model. So I need to make this static as well. Be able to use in another method. My tree model. So my tree model will be like this. And what else we are going to need? Okay, nothing else. Then I will have another method. This will be private static thing predict the class. Okay. And this will codify the input as, let's say I will provide input as a dictionary perhaps, or yes, I can provide this as a dictionary. So I'm going to make a class. I will compose a class to do that. And list say features. So the input features will be this one, this one, and this one, this one. And then what I am going to do is, so this is transforming. If okay, transforming is taking string values array. So I will provide this dictionary string each let's say input. So uh, to transform this, I need string array, and what else I can provide? Let me check it. String value, string input, param string data, data row, data table, column name. So the easiest way is string values. Okay. So we know how many data we will have. Let's say will be based on count and count. Okay. Or oh yeah, I can type it like this. So like this. Okay, then mm, will be equal to okay, and let's continue. So what we are going to do is compose our uh, transform query with like this. Okay, then we have our array string and it will take it like this into the query. Then we will guess, predict, and return the result. Okay, so it will use this static tree. Let's find our tree. Is here and which is here, and okay, we have called our predict class. So before calling predict class, I need to init position tree. Okay, we need to init our decision tree model. Then I will in a while loop. Okay, while true, we will make guesses. Okay, so first it will ask an outlook, and I need to compose a dictionary each time. Okay, and then for each this one, per future, please enter value for this will be outlook and will be read line. However, I need to check possible values of outlook normally, but to finish it quickly, I will not check it, and I will add it to the dictionary as like this feature and read value. And once all is done, we will predict the features. uh, dictionary, and then continue with key. I will write the predicted results. So this application will take values of each feature and make a prediction until forever, because while true. Okay, please enter value for Outlook. The Outlook can take sunny, overcast, and rain. Let's make it rain. Okay, enter. Please enter value for temperature. Temperature can be hot, mild, cool. Let's provide rain and cool. Okay. Humidity. Humidity can be normal or high. Let's enter humidity, rain, cool, and normal. Okay. And for wind, for rain, cool, and strong. So the answer will be no. Okay. It has given me an error. Why? We have entered the dictionary. We have outlook rain, temperature cool, humidity normal, wind strong, and array string has. Okay, our array string is problematic because we didn't increase the index. Therefore, we have to re-enter. You see there were an error. So I will enter rain, uh, cool, normal, and strong. So the answer will be no. Okay, again there is an error. Outlook. Okay, because we have to provide the value here. Okay, and try one more time. Sorry about that. So rain and then cool. Okay, and then normal and then strong. Okay, predicted result is no. And then for continue, I am pressing any key. Then it says please enter value for Outlook. Let's try this time. Overcast, hot, high, weak, and predict value is yes. So let's try something that doesn't exist. Okay, and try to predict it. So for Outlook, I will enter overcast. For temperature, I will enter mild because there is no mild when the outlook is overcast. And for humidity, I will enter normal. And for the wind, I will enter weak. Okay. So it has predicted this one as yes. Let's check it out whether it exists or not. So for outlook overcast, yes, we have. And for temperature as mild, no, we don't have mild. Oh, we have mild. Okay, this one. So this one is matching. And for humidity normal, okay, we don't have humidity normal when overcast and mild temperature. And we have weak. No. So there is no weak and normal humidity and weak wind. It has predicted a result for a data that it didn't see in the training set. Okay, so this is what machine learning do. So when outlook is overcast and temperature is mild, and humidity is normal and wind is weak, we go for a play tennis. And let's try again. So I will try this time, let's say rain, temperature is hot, humidity is normal, and okay. Oh, we have forgotten entered Outlook, so it gave error. Let's try again. So Outlook is rain. Okay, sometimes this happens. Okay, okay. So rain and temperature is, let's say, hot, and humidity is normal, and weak wind is weak. So these values, let's see. Okay, it said me to go and play tennis. Meanwhile, it is raining. So when there is these values, it says go play tennis. So let's try another one. Time like let's make it sunny, and temperature is cool, and wind humidity is high, and wind is strong. The predicted result is no. Okay. You see, it predicts a result for us based on the model it has learned from the supervised data, labeled data we have given. This is a labeled data. From this labeled dataset, it has built a model for us, and based on that model, now our model can predict uh, uh, results for us, predict results for the data that it didn't see. This is what machine learning essentially is. Okay. So this is kind of the tree it is building. Let's see the full tree. This example. Tree. Okay, whether there is a full tree or not. We can also print the full tree, but I am not sure how to do it with a coordinate. Maybe there is model. I don't know if there's a print method. I don't see print. Okay, maybe there is a image of printed model. Let's see it. Whether there is a full tree or not. I'm trying to find full tree. There is this one, and okay, this is the same data set, and okay, this one also doesn't have that. Let's say okay, this looks like a more complete example. So in our case, it is Outlook Sunny. So from Sunny, we go to this branch, and from there, temperature is cool. So there is no temperature branch in here. It So this is not a complete example. Okay, and it checks for the humidity, and there is no humidity again, and there is wind. Okay, wind is strong, so high, and it predicts as no, yes. So it checks only these two values if you go with sunny and windy. However, I'm not sure if this is the full tree or not. Yes, probably this is the full tree. So when you provide these values, it predicts no. And let's check for the rain. For the rain, it goes here, this branch, and then for temperature hot, okay, no temperature. It will check the wind. For the wind, if it is weak, you see it will say play yes and yes. As you can see, the predicted result is yes. So this is basically what the decision tree is. Decision trees can be very strong for categorical data sets where there is a finite number of features, where there is not a lot of features. So you need to, let's say, you need to decide which algorithm to use when select you are working with a certain data set. So you see this tree is built as based on this data. When the outlook is overcast, always play tennis. So if we provide outlook as overcast, whatever the other values we provide will not make any changes based on this model. And the accuracy of your model depends on the training dataset you provide and how well you can describe your features. Okay. Alright, so we have provided a full example of real world data with decision tree ID3 algorithm, decision trees and ID3 algorithm. This can be used in categorical data sets easily. It can be also applied to numeric data sets. However, you would be needed to convert them into the distinct values, such as we use it here codebook to codify into the distinct values. Okay, so you should try to understand what we have done in this lecture. I think I will continue to next lecture in the next week because this was an important lecture. I want you to understand it perfectly. I can change this dataset myself. For example, I can add more rows. However, it may reduce my accuracy. So I'm going to write the learning accuracy to the screen, modified dataset. Okay, okay, we learn the model here. We calculate the error. Learned, let's say model training accuracy is equal to. Okay, and it is by default 100%. Let's run it, you will see it. Okay, so the model accuracy is 100% at the moment. Then I will add my extra data. Let's say it is rainy and it is cold and humidity is high and the let's say temperature is I mean the wind is strong. I will say no, and I will add if it is rainy and if weather is hot and temperature is high and the wind is strong, I will say yes. I will get it confused a little bit, and let's see the accuracy of training set. You see, if your data is not good enough, you may not obtain 100% accuracy in your training model. However, it is also not our aim to have 100% training accuracy each time, because it may lead to overfitting, as we saw last lecture, as at the previous lecture. What we aim is composing a model that will be general as much as possible and that will predict unseen data correctly as much as possible. Okay, so if rain, hot, and high, and let's say big wind, I will say yes, and I will add another one. If rain and cool and high week, I will high and weak, I will say no. Let's see if the training accuracy is um, now lower or not. Okay, still 100%. It learned this model as well, and I will make the data unstable. This. You see same features, however, it will be yes in this case. So we can say that this is an erroneous data. This data is not good. This data is incorrect because with same features, it outputs yes this time. And let's see the training accuracy. You see the accuracy is now lower than 100%. I can make this data even worse, like this, 20, and I will say this time yes. So I added another incorrect data to our dataset, and the training accuracy is now even lower. However, still very strong, even though we have erroneous data. Okay, so you can try yourself at home. Actually, you may try this with another dataset. You can codify it and train a model on it and check the training accuracy. It is totally up to you. So the input is here. Symbols here. Okay, all right. It says you can use instead of this jagged. Let's try whether it works or not with jagged. Okay, yes, it works. So they have separated the two array. Instead, they use now two jagged. Okay, let's change another one as well. So our code will be most updated one. Alright, so we will start next week. This one I'm going to remove it for this week, so you won't get confused. I think this is enough for this week. And there was another error. I mean another example. in the official page of Accord framework, which we are using. Okay. Okay, so they built a model based on Wisconsin diagnostic breast cancer, and it has 569 data. And this one uses cross-validation. In cross-validation, we split our training data into the different splits, and then we use, let's say, 9 of them as training and 1 of them as test to test the accuracy of our model with cross-validation. Okay, and I think this example is also good. I will make it so you will get more idea before we end the lecture. So to do that, uh, I will comment this line. Okay, let's read it.
Ensure we have reproducible results.
So we set the generator seed as 0, so we have reproducible results. And
Get some data to be learned. We will be using the Wisconsin's diagnostic breast cancer dataset, where the goal is to determine whether the characteristics extracted from a breast cancer exam correspond to a malignant or benign type of cancer.
okay, so we generate data like this. This is a method they have coded. Okay, it requires me to add Accord Statistic Analytics, and it requires me to, okay, so this method is not existing in any of the framework right now. To get this, C45, okay, I wonder where this data exists. Let's check it where it is existing. Okay, so the data is available here. However, you need to process it to make it as features. Also, okay, also it is available here as well. Okay, you see, yes, same data set. And let's search it inside Accord framework, so maybe I can find it. Okay, it is inside Accord dataset, so I will add it from my NuGet packages. Installing. Okay, so now, okay, now I have it. And to have cross validation, I need this one. Okay, now I have everything, and let's see the data it generates from this method. Okay, so our data is here. You see it has 569 class labels, which are the output, whether the patient has cancer or not, or let's say, yeah, malignant or benign of type of cancer. And then we get the data features into the double array. This time it is 30 dimensional. It has 569 samples and 30 features. Let's download it from official place to see what data it has. Okay, data folder and unformatted data, perhaps this one. I'm not sure. Okay. Okay, not this one because it doesn't have 30 features. Names. Okay, this one perhaps. Data and names. Okay, not this one either. No 30 features. Okay, there is data CSV here. Maybe this one. How do I download? Okay, not that one as well. Okay, number of attributes 32, ID, diagnosis, and 30 real valued input features. Okay, I'm trying to find the original dataset. Okay, here, data zip. Let's download it. Also requires some downloads, and I think from GitHub we can find it. I will need the raw data. This one, okay, not this one either. Maybe this one. Okay, yes, this is the real world data. So it has ID, and we need to read the definition. I think definition was somewhere here. Text perhaps. Oh, not this one. So the definition was here, I guess. Yes, dataset description. Okay, so title, source information, creators, donors, first usage, literature, number of instances 569. Let's see it. Okay, that isn't enough. Yeah, the ID diagnosis okay, or B. Okay, not this is not the data we are looking for. Okay. Okay, this is the data we are looking for. You see it has 569 records. First one is the ID of the patient and second one is the class of the data. So it can be either B or M. You can read more information here. Malignant or benign. And the 30 real world data. Yes, these are the attributes of the data and they are real valued. And so the real valued features are radius, texture, perimeter, area, smoothness, compactness. I think they didn't list all the data somewhere, all the attributes or features somewhere. Anyway, in any algorithm you use, you need to compare same feature with same feature. So the first attribute can be only compared with the first attribute or of the another record of the another patient. You see, like this. So now we have this data loaded into our dataset like this: class names, benign, malignant, class labels, and features. You see, for example, let's take the first patient and compare them. 17.99 and okay, 17.99. You see, so we have loaded this data into the dataset like here, and we composed the double array as input. So let's compare it. You see, like this. For example, the fourth void attribute is 1001, and let's check it out. 1001, yes. By the way, each one of these data relates to some specific features, some specific features of this, let's say, research. I wonder if they released somewhere the full data of the data names of the features. Okay, perhaps this one or this one or this one. Let's check each one of them. Okay, so you only listed 10 real valued features and other feature names I couldn't find in the. Okay. So they calculated three values for this feature. So 10 feature became 30 features, which are mean radius, radius, and worst radius. Okay. For instance, field 4 is mean radius, field 14 is radius, and field 24 is the worst radius. Okay. So they have uh, taken these features of research and turned them into the features to process in artificial intelligence, which are radius. I will make it by Chrome. Okay.
10 real valued features are computed for each cell nucleus: a. Radius, mean of distances from center to points on the perimeter; b. Texture, standard deviation of gray scale values; c. Perimeter; d. Area; e. Smoothness, local variation in radius lengths; f. Compactness, perimeter squared, area 1.0; g. Concavity, severity of concave portions of the contour; h. Concave points, number of concave portions of the contour; I. Symmetry; j. Fractal dimension, coastline approximation. 1.
Okay, so it explains how they calculated these features. Okay, let's read some relevant information.
Relevant information: each record represents follow-up data for one breast cancer case. These are consecutive patients seen by Dr. Wolberg since 1984, and include only those cases exhibiting invasive breast cancer and no evidence of distant metastasis at the time of diagnosis. The first 30 features are computed from a digitized image of a fine needle aspirate (FNA) of a breast mass. They describe characteristics of the cell nuclei present in the image.
So this is how they calculate, how they composed the dataset. They computed 30 features from digitized image of fine needle aspirate. Let's see if those images still remaining. This is a very old dataset. Okay, looks like they don't anymore. Okay, let's read more. So when you have a problem, you also need to turn that problem into the features to process with artificial intelligence and machine learning. If you can't featurize your problem, if you can't turn your problem into the features, you can't process them. You can't do anything. This is the one of the hardest part of artificial intelligence, perhaps the hardest part. Describing a problem in real world as features that can be processed by the computer.
The separation described above was obtained using multi-surface method tree (MSMT) K.P. Bennett decision tree construction via linear programming. Proceedings of the 4th Midwest Artificial Intelligence and Cognitive Science Society, pp. 97-101, 1992, a classification method which uses linear programming to construct a decision tree. Relevant features were selected using an exhaustive search in the space of 1 to 4 features and 1 to 3 separating planes.
Okay, not much important. Okay, so then as an output, we use the class labels. So we have the output here. These are the whether they are malignant or resin, uh, benign, sorry. So then we use cross validation to calculate performance. A decision tree with a maximum tree height of 5, where variables are able to join decision tree path at most 2 times during evaluation. Okay, so for cross validation, we will be using tenfold cross validation. We will see what is tenfold cross validation later, or perhaps let's just look at it. Okay, let's read this. Perhaps there is a better. Okay. This is an important thing, so I will make it read. Let's read this part first.
K-fold cross-validation. Cross-validation is a resampling procedure used to evaluate machine learning models on a limited data sample. The procedure has a single parameter called K that refers to the number of groups that a given data sample is to be split into. As such, the procedure is often called K-fold cross-validation. When a specific value for K is chosen, it may be used in place of K in the reference to the model, such as K equals 10 becoming 10-fold cross-validation. Cross-validation is primarily used in applied machine learning to estimate the skill of a machine learning model on unseen data. That is, to use a limited sample in order to estimate how the model is expected to perform in general when used to make predictions on data not used during the training of the model.
So this is important. If you use the data that is used when training the model, you will likely to get the correct result because on that data it is already trained. What we want to achieve is high accuracy on the data that it didn't see during the training. However, since we have limited data, we use k-fold cross-validation to obtain maximum accuracy with limited data.
It is a popular method because it is simple to understand and because it generally results in a less biased or less optimistic estimate of the model's skill than other methods, such as a simple train-test split. The general procedure is as follows: shuffle the dataset randomly. Split the dataset into K groups for each unique group. Take the group as a holdout or test data set. Take the remaining groups as a training data set. Fit a model on the training set and evaluate it on the test set. Retain the evaluation score and discard the model. Summarize the skill of the model using the sample of model evaluation scores. Importantly, each observation in the data sample is assigned to an individual group and stays in that group for the duration of the procedure. This means that each sample is given the opportunity to be used in the holdout set one time and used to train the model K one times. This approach involves randomly dividing the set of observations into K groups, or folds, of approximately equal size. The first fold is treated as a validation set, and the method is fit on the remaining K-1 folds.
Okay, I think we can find some image to display. Okay, this one looks good. From Wikipedia, let's open the image. Okay, so this is SVG data. Okay, so we split data into the K group, and at each iteration we train a new model and test the data and calculate accuracy. Then when all iterations are done, we average the accuracy and see how our algorithm performs. So in the first iteration, this is the test data, and this left is this. I will copy this. Okay. So in the first iteration, this is our test data, and these remaining are our training data. So based on this training data, it will compose a model, and we will test this test data on that model. So there will be a accuracy A. Okay. Let's make it a little bit bigger. And then in the second iteration, it will compose a new model based on this data. Okay, and that model will be tested with this data. So it will have accuracy B. And in the third iteration number will be equal to the number k, number of grouping. Okay. By the way, this test data is 1 over k size, and this will be k minus over k size. So let's say your data is you have 100 records in dataset and you use tenfold. So each group will have 10 records. So the test size will be 10 and training size will be 90 each time. Okay. Okay. So as like it will be like this. So we will be using the cross validation. This time it will be using C45 learning algorithm with defining maximum tree height as 5 and decision path is 2. Now we have to specify how the tree performance should be measured. We will be using loss method as actual, expected, and it will have fit. Okay, finally we have to pass the input and output data that will be used in cross validation, input and output. Okay, let's remove it so we can see better. So instead of ID3 algorithm, this time we are using C45 algorithm. This is a different algorithm. We define the loss of cross validation as this actual input, which is and expected input as array, and p parameter expected loss actual. Okay, so where do we get expected and actual? It will be from I think CV. Yes, so the expected and actual will be provided from input and output. Then it will use fit, which will build the model here. So this is the model and it is assigned to uh, fit object and x. So these are, I think, the special parameter names of uh, create methods. Let's see. It takes learner, fit, compute loss, and algorithm. Okay, yes. And input and output as x and y. I. Okay, here. So we can see the result here. I will breakpoint and see it. Okay, let's continue. Okay, so it is doing cross validation. Okay, cross validation is done. Okay, in the result, number of inputs, outputs, samples, training validation, sizes. Okay, so I think this is the accuracy of each training and test. So average accuracy is about I think let's say 57, not good one. Let's continue. Training error. Average training error is this one, and each validation error is this one, and the accuracy is this one. Oh, I think I checked it incorrect thing. So out of inputs and outputs, it's composed general confusion matrix, and from there that we have calculated accuracy. Okay, you can use every one of these in your projects. And so what is general confusion matrix, if you wonder? When I search for it, I think we can find some images. Okay, so yes, this is the general confusion matrix, and you can read about it here. So it is about true positives, false positives, and false negatives, true negatives. Okay, if you want to learn more about it, you can read more about it. I think this is the much easier one to understand. Confusion matrix, so easy. Let's say you have two classes as output, whether it is true or false, and you predict as true, and it belongs actually the true class, so it is true positive. You predict is at negative, and let's say it belongs to the positive class. In that case, it is false negative. Let's say you predict it as negative and it belongs to the negative class, so it is true negative. And let's say you predict it as positive, but it belongs to the negative class, so it is false positive. Actually, so easy. And based on this, you can calculate the accuracy. Okay, so this is what does it do. So the accuracy should be around 92%. Let's check it out. Okay. However, if I change the learning algorithm, which I am going to do here, to Naive ID3 algorithm, ID3 learning, and I'm going to comment this out, and I'm going to remove these two. Let's see what is the success rate with ID3. And if I use ID3, it will require int I double s. Is x should be integer. Okay. Instead of double, it requires me to provide integers. So I have to change this into the integers. If I want to use ID3 algorithm, so I will not break this, and I will make ID3 version. However, ID3 may not work very well. Okay, we will see that. Okay. Uh, okay. For the 5 algorithm accuracy is this one, and 2, and I will also make it with ID3, copy pasting ID3. So to change this, I will make this. I think I need 4. to length. I need. How am I going to do length? Uh, okay, so I am going to iterate this gets the total number of elements in the array, and this is double array. So okay, this is like this. So I need to get a length of 1 and 0 and 1. What I am going to do is make each one 100 times bigger, like this. Because if you multiply every feature with same value, it should not make much difference. Because you are basically making everything 100 times bigger. And since this is a real world data, equal to 100, then I will make it mod floor equal to floor like this, and then I am going to generate another input, integer input. Let's make it temp, and this will be equal to, the feature is not working because it can, yes, not work. It will be as int like this. Okay. And I'm going to make this. Okay. Yeah, this is not the correct way. Not, uh, not this one. Okay, so okay, this gives an error. Okay, so what is the correct? Oh, I see. It will be defined like this, and each time I will be have to like this. Here, here, and so in this I will be good. I'm not sure it will work very well. Probably I don't even need this one. And this time I will use ID learning. And okay, let's check with ID3. Okay, what it's going to do is it will convert data to 100 times bigger data, and so when we convert data into the integer, we won't lose much data. I'm just making a wild guess here, but I'm not sure if it will work or not very well. Pull it here. Actually, this is 100 times bigger. Uh, this. Uh, okay. So when I run the application, yes, I have called ID3. Uh, okay, and you see, for example, this is initialize. Oh, probably I need to get length like this. Yes, this is the correct way, I think. Okay, now it should work. Okay, with ID3, it is taking much more time to build the model and calculate the accuracy. I'm not sure if even if it will work or not. Currently, probably it is in the learn method right now. Let's make it perhaps K2, taking too much, and I will remove the debug mode. Okay, yes. Okay, so ID3 got 84% and C45 has 92% accuracy. If I make it multiply with 10, I wonder will it make any difference. Let's build it and start that debugging. Okay, it gave error this time because we have to, I think, at least 100 times make it bigger so they can be converted to integers. Let's type it with 1000. I wonder if it will make any difference. You see, since our data set is real valued, and when you convert them to the integers, you need to make that there won't be loss of data. You see, this data has three, actually four times at least for Persian, or even bigger than that. Still, we are having some value loss. I will also make it even bigger, so the value loss will be lesser. You see, when you convert this to the integer, it will be 0. When you convert this to the integer, it will be 0. I have to prevent that. I have to keep data as much as retain it. And when I make the data bigger, it takes more time. And you see, when I convert this to the integer, it will be 0. However, when I multiply it with 1000, it will be 11 instead of these ones. So when I multiply it with 1 million, much of it will be retained. However, the algorithm is taking much longer. I think it supports multi-threading as well. By the way, the K2 would yield worse results because you are training with half of the data and you are testing with half of the data. Okay, so it is taking much longer than anticipated. So for real value data, I think C45 algorithm is much better. Perhaps we can add this to this algorithm as well. I am not sure. And I will make this one even bigger. And let's build it. Another thing in machine learning and artificial intelligence is that the parameter tuning. The, the tune of parameters of algorithms can make huge difference. Okay, it can change your success significantly. As you can see, my memory is almost 100%. I'm going to stop the application before it is too late. Okay. You can play with the numbers and the parameters at the home. So I am going to remove this for now. Okay. I'm going to upload this to the our GitHub repository. Okay. Please see you at the next lesson. Stay safe from coronavirus 19, COVID-19. Okay, end of lecture. See you.